become the inverse function sine inverse of 1 by n. So here what we observe is if the value of m, if the Mach number is greater, when the Mach number will be greater, when the speed of object is more and more and more. So as we already discussed about the shock waves, when the object moves with the speed, when the object is supersonic, means the speed is the speed of object is greater than that of speed of sound. It will be supersonic. Okay, this some part is there. It's going with the speed greater than that of the speed of sound. So we'll get some shock wave, isn't it? This some horizontal I'm marking, along which we have the velocity of this object as VO. This is a vector, the velocity of object, which is VO. Now we'll have something like this, the conical projection. This cone we are going to have. So this is VO, and we'll have many circles like this. They are in the form of wavefront, and it will be having the greater radius, and finally you are having something like this. So this is a cone, and you draw a tangent to it. So the normal, in normal direction, if this is the path, if this is the velocity of object, perpendicular to it will be this way, there will be the velocity of sound. Because all this wavefronts are moving backwards, we are getting the cone, and this is the apex. So for this is the apex. This is the velocity of object VO, that can be represented as this vector. This is VO, and the normal, you take any point and you have a normal. This is a normal. So this normal vector will be representing Vs, velocity of sound. Let the vector be this much only, then also it's fine. Okay, so let this be Vs. आगे भी जा सकता है of course. So this be Vs, and let's end the arrow over here. This being VO, speed of object. आगे भी जा सकता है of course. Fine. So this the semicone angle is famously termed as the Mach angle, and the symbol can be alpha, beta, gamma, delta, theta, whatever, but mu is more frequently used. So this angle, this is 90 degree, let me tell you. This is a normal. This angle is Mach angle, mu. So if we zoom it, we'll get something like this, a triangle. This is 90. In triangle, this is 90. This is representing VO. This is representing VS, and this is mu. This angle is mu. That is Mach angle. So sine theta is opposite upon hypotenuse. So sine of mu is opposite is Vs, hypotenuse is VO. We know that Mach number is a speed of object upon speed of sound, that is VO upon Vs. So this Vs upon VO is inverse of this. That can be written as 1 by n. Therefore mu will become, sine goes there, harmonic will become the inverse function, sine inverse of 1 by n. So here what we observe is if the value of m, if the Mach number is greater, when the Mach number will be greater, when the speed of object is more and more and more. If the m is greater, mu will be less, means the cone, the kind of cone that will be getting, that will be of apex. There can be different cones. So here you can easily observe that this angle is more. Let's say this is mu1, this is µ2. Of course µ1 is greater than µ2. So this Mach angle, when the Mach angle is more, when the Mach angle is less, it depends on Mach number, and that Mach number is also dependent. Vs is constant, it's dependent on Vo. So if Vo is greater than Vs a lot of time, 2 times, 3 times, 5 times than Vs, the Mach number will be some higher value. If the Mach number is relatively higher value, mu, which is Mach angle, will be low. So the faster the object moves, the cone will be narrower. The slower, relatively, I am saying, the slower the object moves, the cone will be expanded or extended, having the greater Mach angle. Okay, fine. So this is the representing Mach angle, that semi-cone angle, sine inverse of 1 by m, where m is particular ratio we are aware of, Mach number. So that's it. We'll show this derivation, simple 2-3 steps derivation. Okay, thank you.